Nintendo's final quest for graphic supremacy. Released in the mid-90s, the N64 pushed the boundaries of gaming with its revolutionary graphics capabilities. In this article, we'll explore the inner workings of the N64's hardware, taking a closer look at its CPU, memory system, and the powerhouse behind its stunning visuals, the Reality coprocessor. Let's start with the heart of the system, the Central Processing Unit. Nintendo's choice for the N64's CPU was the NEC VR4300, a low-end variant of Silicon Graphics MIPS R4300i. This mighty processor boasted a clock speed of 93.75 MHz and featured both 32-bit and 64-bit operation modes. With 32 general-purpose registers and the advanced MIPS 3 instruction set, the VR4300 was a force to be reckoned with. However, due to cost constraints, Nintendo had to make some compromises, such as utilizing a 32-bit external data bus instead of a full 64-bit bus. Moving on to the memory system, the N64 embraced a unified memory architecture. All available RAM was centralized in one location, accessible by various components, with the graphics processing unit serving as the arbitrator for memory access. While this design saved production costs, it also introduced potential access contention issues if not managed properly. Interestingly, the N64 lacked a direct memory access controller due to its UMA design, placing the responsibility of providing DMA functionality on the GPU. Now let's delve into the memory itself. The N64 featured 4.5 MB of RAM connected via a 9-bit data bus. However, only 4 MB of RAM were accessible to all components except the GPU. The RAM utilized a cutting-edge technology called Rambus DRAM, known for its serial connection and high clock speed of 250 MHz. This allowed for rapid data transfer rates of 500 MB per second, ensuring smooth performance. To enhance memory throughout, Nintendo employed NEC's UPD488170L memory banks, which implemented Rambus signaling logic and doubled the transfer rate. The console's memory management was facilitated by the VR4300 system control coprocessor, which included a memory management unit and translation look-aside buffer. The MMU organized and cached memory, mirroring the physical memory multiple times to provide virtual addresses for efficient memory addressing. Developers could define their own memory maps using the TLB, optimizing usage by selecting the most suitable segments based on their specific requirements. Now let's turn our attention to the crown jewel of the Nintendo 64, the Reality coprocessor. Developed by Silicon Graphics, the RCP was a massive chip running at 62.5 MHz, responsible for generating the breathtaking visuals that defined the N64. The RCP consisted of two primary modules, the Reality Signal Processor and the Reality Display Processor. The RSP, essentially a CPU package, comprised the scalar unit, the vector unit, and the system control. The scalar unit was a reduced MIPS R4000 derivative, optimized for graphics calculations and working in tandem with the vector unit. The vector unit was a coprocessor equipped with 32 128-bit registers, capable of performing vector operations on 8 16-bit vectors simultaneously. Together they formed the backbone of the graphics processing pipeline. The RSP executed commands stored in the display list, a series of instructions and data provided by the CPU, enabling geometry transformations, clipping, and lighting effects. What set the N64 apart from its competitors was the groundbreaking capabilities of the Reality Display Processor. The RDP was responsible for rendering and displaying the 3D graphics on the screen. It featured a unique set of features, including texture mapping, anti-aliasing, depth queuing, and Z-buffering, which contributed to the console's stunning visuals. Texture mapping allowed developers to apply detailed textures to 3D objects, adding depth and realism to the graphics. Anti-aliasing helped smooth out jagged edges, resulting in more refined and visually pleasing images. Depth queuing enhanced the sense of depth by adjusting the color and intensity of objects based on their distance from the viewer. Z-buffering, also known as depth buffering, ensured proper rendering of objects in the correct order, preventing visual artifacts such as overlapping polygons. The RDP supported a display resolution of 320 by 240 pixels, which was standard for most N64 games. However, developers had the option to employ various techniques to enhance the resolution, such as using frame buffer effects or utilizing the expansion pack, an optional accessory that increased the console's RAM from 4 MB to 8 MB. These techniques allowed for sharper and more detailed visuals, albeit at the expense of some performance. Another notable feature of the N64 was its unique controller design. The controller featured a central analog stick, which introduced precise 360-degree control for the first time in console gaming. It also included a D-pad, 4 face buttons A, B, C left, C right, and 6 additional buttons on the back, L, R, Z start, and 2 shoulder buttons. The controller's design catered to a wide range of game genres, providing a comfortable and intuitive experience for players. Despite its technical achievements, the N64 faced some challenges in the market. One notable limitation was the use of ROM cartridges instead of the increasingly popular CD format. Cartridges offered faster loading times and more reliable data storage, but had significantly lower storage capacity compared to CDs. This limited the amount of content that could be included in a single game and made development more expensive. Additionally, third-party developers faced restrictions and licensing fees imposed by Nintendo, which affected the availability of games for the console. Nevertheless, the Nintendo 64 left an impact crater the size of Chicxulub on the gaming industry. It introduced groundbreaking graphics and gameplay, showcasing the potential of 3D gaming on a home console. The console's iconic library of games, including classics like Super Mario 64, The Legend of Zelda: Ocarina of Time, and GoldenEye 007, continues to be celebrated and cherished by gamers worldwide. The Nintendo 64 revolutionized gaming with its impressive graphics capabilities and innovative design. Its powerful CPU, unified memory architecture, and the Reality coprocessor set new standards for console performance and visual fidelity. Combined with its unique controller and a library of memorable games, the N64 remains a beloved console that holds a special place in the hearts of gamers and collectors alike.